Honors Pre-Calculus students, welcome. Monday. I'm not there to go over the class, but make sure you watch the video and take notes. In the last class, we talked about the sigma notation and how we expand the sigma notation and how we collapse. And the homework assignment was on homework worksheet, this 1 through 6 all. I will check this homework tomorrow when I come back to class. So let's see what do we have today. Today, find out page number 9 in your packet and make sure you take notes while you watch this video. Okay, so we are going to talk about sum of the finite series. Okay, so we are going to talk about sum of the finite series. Finite means finite number of sum. So there is a little story about 8-year-old boy who was very famous mathematician, Gauss, and he came up with this idea of how to add the numbers easier way. His teacher was very surprised how he got the answer. So let's say that he was given a job to add 1 through 100 number. He was only 8 years old boy. And it's very interesting that how he came up with the idea. So what kind of sequence is a set of integers? This is a arithmetic sequence. Common difference D is a 1. Okay, so let's talk about what kind of function would model this sequence. Arithmetic sequence are always a linear function. A linear function, and the rule for this is n. And always arithmetic sequences are linear functions, and the common difference D is a m. So m is the same as a t. Okay, so moving on, how he added this sum. So what he did is 1 plus 2 plus 3 and 98 plus 99 plus 100. So what did little Gauss did? He reversed this series. He flipped it. He wrote backward. Think of this way. And what he did is he added all these numbers. So again, let's check. If you add this number, it up to 101. 99 plus 201, 98 plus 301, 101, 101, 101. So basically, he added whole series twice. So how he added the come up with the sum is the first number and the last number, and there are 100 numbers. Divide by 2. So he came up with this idea. It's so super cool that such a brilliant boy that 100 plus 1, 99 plus 2, they all add up to same number. You are supposed to add only once. That's why we divide by 2. So what is the general rule for this? The general rule for this is sum of nth term is total number of terms divided by 2, first term and the last term. And this formula is given in the formula sheet. Okay, so remember I told you in the class that our focus is always geometric series. So that was about arithmetic series. Now let's talk about the geometric series. So 3 times 6 times 3 plus 6 plus 12 plus all those numbers. There is a comma, so that's why we call this a sequence. What kind of sequence is this? This is a geometric sequence because common ratio r is a 2, and each time you multiply by 2, that's why we say that this is a geometric series. Sorry, sequence. This is a geometric sequence. What kind of function is always exponential function, represents geometric. So rule is an is first number is a 3, common ratio is a r to the n minus 1. Again, this formula is given to you in the formula sheet. The geometric series sequence is, the rule is this. So in this case, r is a 2. So that's what the rule is. Now find the sum of this series. So here we are just adding these numbers and we can came up to 381. Okay, so our focus is geometric series and sequence and series, and next we are going to look at this. How do we come up with the formula for the geometric sequences? So let's flip the paper to page number 10. Sorry, page number 10. Sorry. Okay, sum of finite arithmetic sequence. This is page number 10 in your packet. Okay, so formula will be given to you. This formula given. We are going to look at some examples how to do those. And I have some ready notes given to me, but this is posted in the classroom. Okay, so let's check this out. First term is a -8. Last term is a 34. But we don't know how many terms are there. And we have to find the sum. So we can say sum of how many terms we don't know. First term is -8. Last term is a 34. Divide by 2, but what will be this number? Well, here the middle missing number is each time you are adding 7. So the first term is -8. Last term is 34. The rule for the last term is a1 plus n minus 1 times d is equal to 34. A1 is -8, n is I don't know. Common difference d is a 7. Each time we are adding 7. So you have to solve for n here, and n will come out to 6. If you solve this, 34, oh sorry, plus sign, 34 plus 8 divide by 7, which is n minus 1, and if you add 1, n is equal to 6, and that will be the number 6 here. Again, geometric sequence and series is our focus. We are just going through some arithmetic sequences because in the couple of problems in the homework is very similar to this. You can use a calculator to do the homework, but most of the numbers in the assessment is going to be without calculator, and the numbers would be manageable. Okay, so where do we use this? This is a very typical word problem here. Corner section of the stadium has 8 seats. Front row, each successive seat has 2 more seats than the preceding seats. Top row has 24 seats. How many seats are there in the entire section? So pretend that the first one has 8, then the 2 more, and the 2 more, and the 2 more. So this is like 8, 10, 12, like that's typical stadium section is like increases in each time. So the first term is 8, last term is 24. All we need to know how many terms are there. And n is 8, so there are total 151 seats in this section. Let's take a look at the geometric sequence and sum of the geometric sequence. This is going to be our focus on this part. So one more time, calculator is not allowed. So let's check this formula. This formula is given to you. Now, unfortunately, there is no story to come up with this, how we came up with this idea and who was the one who came up with this idea. We don't have to worry about that. Just know that this is the sum of finite geometric sequence where R is the common ratio. And how do we add these numbers without calculator? So let's take a look at first one example here. First term is a 9. A1 is a 9. A1 is a 9. So sum of n represent number of terms. So how many terms are there? So you can say that this is 7 to the 0, 7 to the 1, 7 to the second, 7 to the third, 7 to the 7. So if you start from 0 to 7, there are 8 terms. So sum of 8 terms is A1 is a 9. 1 minus, what is R? R is, you can say, each time you are dividing by 7. In other words, you are multiplying by 1 over 7. To the n is a 8 over 1 minus 1 over 7. Okay, so how do we add these numbers? You can say that 1 over 7 to the 8th power is going to be very, very small number. So we are going to ignore that, and 9 over 1 minus 1/7. 1 minus 1/7 is 7 minus 1/6/7. And this number is 9 times 7 over 6. And that is the sum of first 8 terms, which is 21 over 2. So know this kind of problem, and we have to see that if the number is very, very small, for example here 1/7 to the 8, because 1 over 7 and to the 8th power is very, very small number, we can ignore that. So very similar here. I'm just going to explain from here. Sum of a first 4 terms. So n is a 4. S sub 4, first term is 15. R is a 1/3. 1/3 to the 4th over 1 minus 1/3. Formula is given to you. A1, 1 minus r to the n over 1 minus r is a sum of n terms. This formula is again given to you, and you just have to use it. So here, why didn't we ignore 1/3 to the 4? Because 1/3 to the 4 is not that small number. We can say 1 over 81, because 3 to the 4 is 81. 1 minus 1/3 is 2/3. 1 minus 1 over 81 is 80 over 81. And we simplify to this number, and you can stop. Now in the assessment, I will accept this answer as well. You can stop here also, stop. So formula is A1, first term, 1 minus r to the n over 1 minus r. Now here, another example, this says sum of the first 4 term is 60. So that means you know what is the sum. A1, common ratio r is 1/2. 1 minus 1/2 to the 4 over 1 minus 1/2. And you have to find the value of A. 1 minus 1/2 is half. Half times 60 is 30. 2 to the 4 is 16th. 30, this number will be 30. 1 minus 1/16 is 15 over 16. And the first term is 30 times 16 over 15, which is same as 32. I have done that problem different way. You can see here, you can pause and check how I did. But that means the first term is 32. Okay, so what's the big deal about all this? Well, our ultimate goal is to check infinite geometric series. That's what. So we are still getting familiar with the partial sum. So let's flip the paper and check it out about the infinite series and infinite geometric series. Okay, so this is your page number 13. Okay, sorry, this is your page number 12 in your packet. Take a note up to here. We are going to check up to here. We will see. Okay, so what is infinite series? Infinite series means sum of infinite many terms. Know that. Okay, so what is the partial sum? Partial sum means a sum of some terms. Partial sum means the word part means part of the sum. Partial sum means part of the sum. So S sub n is sigma notation 1 through n, sum of n terms. Now we have to see the limit of the sequence of partial sum. So we are going to predict what happens if we go to infinite many terms, if we add infinite many terms. So this is very important notation here is if n goes to infinity, if partial sum converge, then the sum converge. That means you are going to predict by adding few terms to see if my answer exists if I add infinite many terms. So we are going to just look at part of the sum. Like for example here 1 plus 1 half plus 1 fourth. Do you see the numbers are getting smaller and smaller and smaller? So we are going to check it out. If what happen if I add first term, the sum of the S1 is a 1. S sub 2 is 1 and 1 half, which is 3 half. S sub 3 is 3 half plus 1 fourth. S sub 4 means 3 half plus 1 fourth plus 1 eighth. And onwards. So we are going to predict what happened if I add infinite many terms. What happened if I add infinite many terms? So for this part, we are going to check the sum exist or not. So sum of nth term is what happened here. So we can see that formula exists or not. So this space here, the sequence of partial sum would fail to approach if the last term, nth term, did not approach 0 as that's infinity. So I'm going to skip this part. Is if n goes to infinity, what does s of n approaches to? The answer is 2, because if we add all these numbers, you will see that number is getting closer and closer and closer to the 2. Excuse me. This is just a part of the deriving how we got this answer. The answer is going to be on the next page, and we just have to know that formula. Given the example of infinite series that does not have a finite sum. So biggest example is exponential growth function. Exponential growth functions are, for example, if I can say n is 1 to infinity, 2 to the n, this sum does not exist because this r is greater than 1, which is exponential growth function. And we can say that this is infinite geometric series, but still sum does not exist. Another example is here, r is a 1, infinite geometric series. Sum does not exist because it fluctuates between two of them. So when does the sum exist? So let's take a look at the next page, which is your page number 13. Page number 13. Now this page has all the formulas given to you. How to, this is optional, how we came up to this formula. Remember on the couple of pages before that I told you this is the formula given to you in the formula sheet. So this is just a proof how we came up to this. Feel free to explore if you are interested, but again this formula is given to you, so I would say just don't worry about that. Now let's derive the sum formula for the infinite many terms. So this is infinite many terms. What happens to this formula? So here r approaches r to the n, and n approaches infinity. So in the previous example, remember I told you that 1/7 to the 8 is very, very small number. So think about here, if n goes to infinity and r is 1 over 7 to the n. What would be this number? This number becomes very, very small. How small? 0. In other words, exponential decay function has a horizontal asymptote 0. You can see that. So what happened to this formula is sum of infinite many term is a 1 minus r to the n become very small over 1 minus r. And that is the formula you are going to use all the time. This is so popular, so famous formula, which is nothing but first term over 1 minus r. So I have explained here different, same thing here, n goes to infinity, r to the n is very, very small. The whole thing is very, very small, and the left is a over 1 minus r. But this is only possible if and only if r is less than 1. If and only if r is less than 1. So what's the sum? We proved that how come these numbers, if you add infinite many terms, how that answer is a 2. This is the formula. First term over 1 minus r is a 2. Sum of infinite many terms is 2. Okay, so more detail we will be doing tomorrow in class, but another nice example is here. Think about this paper. One paper, you fold it in a half and half and half and half. How that becomes 1. So you can say 1/2 plus 1/4 plus 1/8 plus 1/16, 1/32. All those triangles become smaller and smaller and smaller, this part. And you can see that there is a 1 rectangle. So infinite many rectangles, and infinite many small triangles, you add, it become 1 square. So this is the visualization of how 1/2 plus 1/4 infinite many, you add, it become 1. Okay, so tonight's homework is you are going to work on homework number 1, 9.5 worksheet. Remember, you have already written all this sigma notation. You are going to work on this rest of this problem here. 7 through 12 is a arithmetic sequence. Formula is given in the formula sheet. What's the formula? I'm going to write again here. It's a n is n over 2, first one plus last one, and sum of an is a1 plus n minus 1 times t. These formulas you are given in a formula sheet. Use that for this problem. The second part, geometric sequence, sum of n is a1, 1 minus r to the n over 1 minus r. Again, refer to the formula sheet. Formula sheet is given to you. Nth term is a1 r to the n minus 1. Use this formula, and this is the homework you will be working on tonight. Now I'm going to also assign some of the sigma notation for the practice. Sigma notation is very important one. So check the canvas for the links, and I'm going to stop here. I will see you tomorrow in class where I will check this homework, summation notation, and this rest of this. Thank you so much. I'll see you tomorrow.